Welcome, everyone, and thank you for joining us. This is the grading optimization session, Making Choices that Benefit Automatic Grading. My name is Russ Nicloy. I'm a Civil Solutions Specialist with Macer Technologies. I've spent about 30 years in the industry between roles in production as well as some time with a reseller. And over that period of time, I've gotten to see a lot of different aspects of the civil industry. One of the things that's not on this card here is that I was involved in a productivity study commissioned by Autodesk to compare Civil 3D traditional grading tools with the grading optimization tools that you're going to see here today. Uh, it was during the learning phase of that, because grading optimization is new to everybody, reasonably so, and I needed to get proficient with the grading optimization for that study. And I started realizing that there were things about it that I had either misunderstood or misinterpreted, naming of tools and so forth. And I was starting to learn how those tools worked. And I realized that this would be a great topic for Autodesk University to share with those that might be looking into grading optimization so you can take it back to your organizations. So a little bit on the agenda here today, we're going to be looking at zones, lines, and points. These are the actual grading objects that we're working with, things that grading optimization is going to use to finish the resulting surfaces. We're also going to look at visualization tools to supervise the progress of our of the grading optimization. That way you can tell if things are going in the right direction or not, and if you want to stop and back up and fix things. Also, how to encourage drainage. Now, I like the term encourage here because it is not just putting lines in and saying, well, I want a ditch here and a beam here. You can go in and say, well, I want the surface to kind of do this in this area, and then let grading optimization figure out the specifics about how to accomplish that. And then finally, we will be looking at balancing volumes and other objectives. This is where we're going to tell grading optimization what we really care about of this project. Do you want to balance the cut and fill, or do you want to make sure that there's not too much elevation change throughout the course of the project? And those are very important tools as we start to finish up the development of our optimization here. So before we get started or too deep here, I am going to get into a short introduction to grading optimization. It's a new enough tool that I want to make sure that everyone is on the same page with what this tool is. It is for optimizing. It's not just a clever name. It literally is optimizing the grading of your project. The user, you, will provide an envelope of parameters that will allow grading optimization to run in between those areas, basically letting it know what you care about and what things you have to hit. Now, it's very much like you have a very, very large room full of engineers, and you're giving each engineer a task to run or try out in a grading situation. Although it's better than that, because first of all, it's going to go much faster than a room full of engineers would necessarily, but it also returns with the best or the optimal result from all of those options. So you're saving a lot of time and a lot of effort in the use of this tool. Now, also some suggestions for use of grading optimization. I don't know that it's always the best for every project. For those projects that are over-constrained and have a lot of parameters that you can't bend or break, it may not be the best tool for that. I was joking with an engineer the other day that how often our projects are so limited that we don't really get the choice, and the projects design themselves for us, and they tell us what they need to be. For those, the grading optimization may not be what you want to use for this. Grading optimization is actually good when you've got a little bit of room, and a couple percentage or a little bit more slope here or there, a little more distance here or there. Things like that are where grading optimization really shines and provides the better result for you. Also, limit your limits. What I mean by that is that parameter envelope, don't always mark it to the absolute strictest numbers unless you have to. Give it a little room to breathe. If you're trying to hit a 3%, maybe let it go to 5% if you're allowed to. Many times those things will work themselves out, and you'll be fine in the 3% area, but you might have a little bit of area that needs to go to 5, and it'll find that for you and put that in. Also, do grading in phases. This is something that that was mentioned to me early on, and it really changed the way that I looked at grading optimization. Um, and I don't mean in phase one or phase two of a project. I mean I'm going to make a grading of the larger overall area that I'm concerned with, and then I'm going to move into more localized area for a little bit more detail. That way, when I'm in the more localized area, I'm not grading the whole project every time. I'm just working on those little localized areas, and that cuts down on time, but also does not ruin some great grading that's happened outside of that area. In terms of grading in phases, you'll want to adjust the grading limits or the extents of the grading. That is, we're going to start off with the grading limits on the outside edge, but then move it into that more localized area. And you can have more than one grading limit. You just have to turn them on and off as you go between the areas that you're working in. Also, set preferences for speed versus quality. If you're doing a preliminary grading early in the project life cycle just to see if this is going to work or not, is this a project we should pursue, you can turn the mesh quality down or the refinement off or the iterations. By default, the iterations are set to 100,000, so that's a lot of options to run through. You could turn those all down and get a little speed back into this so you get a faster result, but you would be losing some quality. If you turn those up, if you tell it to go to the higher mesh quality, go for a higher refinement and more iterations, you're going to get a better quality, but it might take a little longer. So balance that out for the phase of the project that you're working in. Also, you don't have to accept the results just because you let it run to the end. Many times I will stop a grading in the middle because I see that it's going in a direction I don't particularly want, or it'll end up with something that I don't want to finish with, or I'll see something, oh yeah, I've got to add this in there. And you don't have to accept the results. You just back up and add those things and rerun it, accepting the results when it makes most sense for your project. So I did move the visualization tools up to the top of this agenda just because it's going to be so integral to what we look at here. We'll be looking at what goes on with the visualization tools, and I wanted to explain those right away. The visualization tools are going to be a toolbar that opens up when you run an optimization. They are for colorizing and visualizing the surface as it's being developed. This will open up when you start the optimizer, but you can open and close it from an icon in the lower left of your screen. I've got it marked on the screen there. Going left to right, generally, we have our result graphics. They're going to be things like a heat fill, a heat map of cut fill, also violation triangles, which will colorize triangles to let you know where triangles are not quite meeting your parameters. If you turn those off, though, it shifts us over to theme. Theme is going to color band or grayscale band elevations or slopes of triangle faces. Topology is going to be whether you're looking at it as contours or triangles. I personally really like the contours. It works with the way my head works, but many times the triangles can be useful for identifying where things are working, where they're going wrong. Beyond that is hydrology. If you're using drainage lines in this, and that's something that we will look into here, the hydrology will show you where the faces of the surface are pointing. Now, I like these particularly because they're very similar to Civil 3D surface analysis, slope arrow tools, and can really help identify where things are sloping to very quickly for you. At the end of the toolbar is a gear icon that opens up the visualized settings. Here you can see that you can control how many contours there are. You can bump up that interval if you're in a really flat area, so you can see some nooks and crannies of the surface. And then also the surface slope area. The number of ranges is there. The advanced settings is actually for changing the amount inside each range. Maybe you have one range that's a little bit larger than the others. You can adjust that there. Now, there's also the vertical exaggeration slider that gets its own slide here because it is larger. It's going to be on the left-hand side of your optimizer, and while you're optimizing or at the end of the optimization, you can slide that up and down. Now you'll see on the left, I've got it all the way down. That's a 1-to-1 exaggeration, basically no exaggeration. And then on the right is the full exaggeration. I like to use this when I'm looking for nooks and crannies again, and to make sure that things are ending up the way that I think they are. I can tell a lot of things by the contours here, but I can't always tell things that are happening in between contours, and that this can help point that out. So with that, let's look at zones, lines, and points. Zones are an area of grading. They're going to be a closed shape. You can use polylines or feature lines, however you want to define those. And then you can identify what kind of slope you want to give, a maximum, minimum slope, and how the triangles are going to work inside of them. There is a zone called zone, and just kind of a miscellaneous one that you can use for most things. The one that I gravitate to first is going to be the grading limit zone. And that's going to control how much of your surface is actually being actively graded. There's also things like ponds and building footprints that have different parameters specific to those types of gradings that you will want to work with. Lines are going to be linear location grading. They feel like break lines to me. They aren't always break lines, but I'm going to put in a retaining wall. I'm going to use a line, and it'll feel very much like a break line. Also, drain lines. I'm going to talk a lot about drain lines in a bit here. They are a line that encourages that draining off of a surface, the drainage off of a surface. Also, point objects, which are going to be an XY location of where surface control is going to be. You could do a low point, which is just, with all the other grading going on, it'll make sure that there's a low point at that location. Or you could do a bounded volume or bounded elevation, excuse me, that will take the surface at that point to a specific elevation or between a minimum and maximum elevation. So those point tools, all three of these are very easy to use, and you set them up and grading optimization will integrate them into the work that it's doing. So with that, let's switch over to Civil 3D. And I want to point out, first of all, that all three lines that I have here that I'm highlighting are all just 2D polylines. There's nothing special about them. You don't need to use feature lines, although you could. I am going to go into the Analyze tab and go to the Grading Objects to open up the browser as well as the tools I want to use. I'm going to come down here to Grading Limit. I'm going to use that on this outside edge here. It's a smaller site, but I want to make sure it only grades in this area here. And then I found that naming the sites or naming the zones is very important. This is going to be grading limits. And then for this one, I'm going to make sure that the minimum drainage slope is 0. While that could end up with a flat triangle here or there, that will be very unusual that it would actually do that. But it does mean that the slopes here will be natural to the edges along the outside edge. The max slope, I'm actually going to set that to 50. And actually, I'm aiming at 33%, but I'm setting it to 50 to expand that parameter envelope that I talked about earlier. I'm going to let grading optimization figure out where the 50% might need to be. In fact, the 50% 2-to-1 slope in this hill over here, I'm expecting to probably find some areas there for it. Now I'm going to go to the zone. Like I said, this is that kind of miscellaneous zone tool, and I'll select this one right here. And this is going to be lot 1 pad, so I can find it later. And I am going to set the customized constraints. I'm going to set the minimum drain slope to 1 because whatever else is going on here, we definitely want it to be draining at some minimum percentage. But I'll go to the maximum of 5. Now I'm actually aiming for 3%. Again, I'm opening up that parameter envelope to let it find where this should be. I'm expecting most of the triangles will end up at 1 just by the location of it in the middle of that grading limits. And with that, I'll also go over and use a building pad here to put this building pad in the middle. And in here, first of all, notice I'm going to start at the bottom and work up. The depth of material here is if you're doing a volume calculation, including how much dirt has to be removed for this building footprint. In our case, I'm not going to do that. This is early in the preliminary stages, so I'm going to zero that out. I am going to leave the level grading with pad, so wherever the pad ends up, the surface understands it needs to match up with that. I'm going to leave the elevation turned off. That way it can find where that footprint should be. Optimally, where should that building footprint be? If I was to turn it on, I could do a maximum and minimum elevation, again, with the envelope of where I want this to sit. Or I could click this other button and lock it down to a very specific elevation. So you could say, 843 feet and lock that in. You could put that in. I am going to uncheck that and uncheck the elevation so it does that optimization for me. And with those, I'm going to click on Optimize. And let me zoom around a little bit here. I want to get a good vantage point on our project. I can come over to the panel over here and go in and access like the grading limits or the zone that I've put in and access the properties over here. You'll see that it's the exact same settings that we had when we built them. It also highlights it on the screen. I find that very useful, especially when I'm troubleshooting or trying to run something new. I'm going to click Optimize and let that run. Now I'm going to come up here. It's set to show the errors, and of course the errors there are no errors right now because it's finding surface fairly well. Here's the cut fill heat map, and then I can turn that off, and that sends us over to the theme, which right now is color coding the elevations, or I could grayscale the elevations or find the slopes. I've got a lot of heavy slope in that corner, and I can find that here. Right now, I've got the topology turned to contours so that we can see that and see the contours moving around. But here's what the triangles look like when you use those. The hydrology I can't use just yet. I need a drain line to influence the drainage in one direction, but that is here, and we can turn that on a little later. Now, through the course of me talking there, it has finished all of that grading there. And actually, I want to make some changes here. I'm going to use the exaggeration here to pump this up. This is where that screenshot came from earlier. And I can see, we've got a heavy slope there. And I think that to prevent any heavy slopes through this area, I'm going to put a retaining wall in there. So I'm going to close out this. I'm not going to accept the results, and I'll kind of back out. I'm just going to draw in a polyline roughly where I want to tie it in, up into the hill here. Yeah, make sure that that wasn't overstriking that. Then I'm going to come into the retaining wall and set that in. Now I want to point something out. The line is where I drew it, but there's kind of a shadow to the south of it here. That is the retaining wall height. The shaded side is the high end of this retaining wall. I can flip that back and forth by clicking this button in the menu here. Also, I've got about 9 feet of elevation difference there. The minimum height, I'm going to set it to 1, although I think I want it to start at 3 feet, but I'll start at 1 and see how that goes. The max height is 10, which is close to where we're at. I'm actually going to set that to 15. I'm not expecting it to go much over 10, maybe 11 feet total. But if I set it to 15, that gives it room to run. So with those in place, I'll come back into the Optimize tool. And I will run that optimization, and you'll almost immediately see the wall there. It's a very dark area there. If I use the exaggeration, you'll be able to see that the slope of the hill up to the wall is gentler. It's actually very close to original slope, and then it just drops straight down so that we can get back into a nice slope down below. So that is how that surface is working out. And we're already at 50,000 iterations. You can kind of track that over here. So I know that, it's flattening out. We're pretty much at the best that we're going to get right here. So I'm going to click stop there and back out. And I am going to also go back to my slide deck here so that we can look at how to encourage drainage. This is an important part of the use of the optimization tools. First of all, we're going to look at lines. Drain lines in particular, I've already mentioned them. They are going to either help you create a ditch line area or help you translate a surface or encourage a surface to drain in a certain direction. Now, if you move that line around, you can change where that drainage is. The surface triangles know to point towards that line. The aligned edge line tool is going to allow you to put a line across a surface, and then if that surface is moving at kind of a bump, it's going to give it a constant slope along that line. Now, as it moves away from that, it becomes more and more natural away from that, so it produces a nice grading pattern or a nice drainage pattern off of your surface. Bend line is going to help you relax any parameters that don't need to be in a certain area. Any triangle that touches the bend line is basically going to relax the parameters or ignore the parameters in that specific instance. The offset points look like I put it in the wrong batch, but offset points are actually a line tool. What you do is you identify the lines, point 1 and point 2, and then tell it how much over that distance, how much difference do you want in elevation between those 2 points. Great for when things are really close in and you need a quick elevation connection to an area. The points that encourage drainage include the low point and bounded point. Low point in particular, you place it at a 2D location, 0 elevation or whatever elevation you need to. And then as other grading is going on, it's going to keep pushing that point down to make sure it's the low point. You can set it to be a circular pattern that comes into that point or a diamond pattern, more for like parking lots and that type of grading. Bounded point is where you can actually put an elevation to a point and say, I need to tie into this point here, and you give it that bounded point, and it's going to make sure that that point doesn't move. It kind of anchors it in. Or you could give it a minimum maximum at that particular location and let it optimize in between there. So let's go take a look at these in Civil 3D. First thing I'm going to do here is draw a polyline. Again, just a regular polyline. I'm drawing it outside the extents of the grading because as the surface triangles of this area here, you can see that my minimum drain slope is 1. That means that they're turned on and looking for this line. They will all look for this line and point towards it. If I was to draw this line inside of that area here, the triangles to the west will all point to the line, but the triangles to the east will also point back towards the line and effectively create a ditch. So that's one thing that I had to learn very early on, that if you move this outside of the extents or outside the areas that are grading, it actually gives you a nice gentle slope through an area without having to create a ditch in your design. Now, I do a lot of work with grading through feature lines, so I would naturally progress to a feature line. You don't need to use them, but if, like me, you accidentally do use a feature line from time to time, that will work as well. Now, I am going to highlight that to let you know that the elevation there is 0. I'm not giving it any elevation. I'm going to let grading optimization find that for me. But both of those, I'm going to create a drain line and assign that to those lines there. Hit enter. Now, there aren't any parameters here. It's either the triangles are facing us or not. Because there's 2, some of the triangles will see this line first, other triangles will see this line. So we'll have a nice drainage pattern across our surface here. Another line, I'm going to put in a polyline here in front of the building. And I'm going to put it out to the street. Now, this is not necessarily how you would want to use an offset points line, but I'm going to use it for this to show the functionality. If I click on offset points, I'll select on that polyline. And in here, I could give it a minimum maximum depth or difference, or in this case, I'm going to leave it as a specific number. I'm going to set it to -3. And actually, that's to show a really aggressive setting here. And what's going to happen is it's going to work great. It's going to work generally in the pad area, but then it's going to leave the extents here and not affect the surface any at all after it gets outside. But the idea is that I want this point and a point out here to be about 3 feet apart, and it's going to affect the surface in between there. Another item that I'm going to bring in is a point. I'm going to bring in a Civil 3D point on a surface. I'll just drop that right about here. And I'm using a Civil 3D point, but you could use an AutoCAD node for this as well. I'm going to go into that point and edit it just so, again, so you can see that this happens to be at 849.3. I didn't pick that, but that's the surface elevation where I placed it. Keep your eye on that number, 849.3. And then I'm going to put that in as a bounded point. And when I do, 849.3 is the elevation here. It's respecting the fact that I did have an elevation on it. And you can use that. Or I could set that elevation to be whatever I want it to be. In this case, I'm going to uncheck the fixed nature of this. And I'm going to set the minimum elevation to 845, quite a ways down. And I'll set this to 847. So 2-3 feet lower than its original start point there. And then with those, I am going to go up to my Analyze tab and open the Optimizer. And there you can see, as we're getting in here, you can see those lines are showing up in our area here. And again, you can access them here if you need to make changes. I'm going to click Optimize. I'm going to switch over to the colors here so you can see that near the bound point, that is a very low point, and it's kind of creating a pond there. Also in here, it's creating kind of a weird ditch type area here. If I grab the exaggeration there, you can see that it drops way down. Now this is getting quite ugly in here because some of it is up here in the area surrounding our grading. Some of it's in the pad area. Some of it's outside it completely. So it's getting a little chunky in there. And I'm going to have to stop this because that's not what I wanted. I'm going to stop that. And then I'm going to come over here. Instead of going back to Civil 3 to delete it, which you can do, I'm going to come over here to offset points and simply, well, first of all, highlight it, make sure it's the one that I'm looking for, and then turn on this button. If you move over the top of this text, it actually turns on the button that will turn that off. It'll take it out of the calculation. There's also an eyeball here. I'm going to turn that off so that it just visibly isn't there anymore. This item is still here, and I can always come back and re-energize it again and use it again if I see fit. I'm going to do the same thing for this point here and turn that off. Now, I am also going to reset. You don't always have to reset. The grading optimization tends to do a good job of fixing things back, but I want this to start from the original starting point. And there you can see that. I'm going to click Optimize. And now things are smoother. I do want to turn on the hydrology here because now I have drain lines, and you can see those arrows. There's one arrow per triangle. If I turn triangles, you can see that. And they are indicating where they're angled. So there's a whole bunch here that are pointing towards this line and a whole bunch that are pointing towards this line over here. Now, as you're working with this, if you realize, oh, wait, I need to make an adjustment here, you just stop, go back in and move that line around, and they are still assigned to look at those lines no matter where you have them placed. So with that, I'm going to turn off the hydrology there, and I am going to stop that. It's pretty close to being done. There aren't major changes being done, and we're close to the feasibility being done there as well. I am going to delete that line and the point while I'm here, just so that later on they don't graphically get in our way. Now I'm going to go over and take a look at the balanced volumes and other objectives. The objectives are basically you, the user, telling grading optimization what your intent is here. The tools available are going to be balance cut and fill, minimize earthwork, and smooth surface. You can see in my screenshot there that I have the balance cut and fill set to 0, which effectively removes it from consideration. And then minimize earthwork is up to 100. That's a percentage. And so I'm saying that I'm really interested in minimizing the earthwork here, even if the cut fill isn't balanced out. Smooth surface is going to make sure that any difference between the surface triangles is minimized. Now it's 50%, so it's not the most important thing here, but it is something that I do want to have happen. You can have these set to whatever amounts that you want and weight them, but the more weighing that you do here, the longer this is going to take. So you can really hit some good numbers here using this tool, however. In fact, in my second shot here, I've actually swapped them out and I've changed the balance cut and fill to 100%. And down in the lower left-hand corner of the convergence plots area, you'll see that's where the volumes are being calculated. And you can see when they're balanced at 100%, I've got red cut, green fill that are balancing out, and the yellow net line is riding right along zero there. Now, realistically, when you hover your cursor in that graph, it'll read that, it's going 1 or 2 feet on either side of that, but realistically, very, very close to zero in the grand scheme of the volume calculation of your project. So if we have minimize earthwork as our objective, you're going to see that the red and the green areas are not going to be as well balanced, and that yellow line will be jumping around inside of there as optimization is trying different things to work without changing the elevations throughout the project area. So with that, let's move back here, and I am going to go back to optimize here. And I'm going to go to the optimization options, and that is where the objective weights are stored. I'm going to set the balance cut and fill down to 0 and the minimize earthwork up to 100. So I minimize the amount of elevation change that I'm going to be creating. In a project like this, that's nearly impossible, but I can minimize it or cut it down some. And smooth surface, I like to leave at 50 unless that's my focus. So I'm going to turn that off, and then I am going to run this. Now in here, I am going to turn on the convergence plot so you can see what the volume calculation is doing during that. And you see the yellow net line is kind of bouncing around in there so I can see what that's getting me. Now at this point, I'm going to stop this. I'm actually going to stop it right there. And I'm going to go back and change that setting from minimize earthwork down to balance, cut, and fill. I'm going to use the arrow to open that up, and you can set what your target is. My target's going to be 0. I'm going to try and balance this, all the way out and not truck anything in or out. But if you have a number or amount that you want to hit, you can set that there. Now with that, notice that I did not hit the reset button, and actually you should at this point, and I'll show you why. I'm going to click optimize and go into the convergence plots here, and notice how it spikes up, even though I'm restarting it, and it is coming back down. It will figure out what's better for this area. I'm making it kind of spike up and work harder at that. So if I stopped it and ran it on its own, it would just do a nice smooth feasibility and balance this out. But you can see that even the balancing figured right back to 0 as soon as I asked for that in this. Now, throughout the course of this, I am letting this run out just a little bit further here. I'm not going to get anywhere near 50,000 iterations. I won't need it because it's flattening out, and really the optimization has happened here. I'm going to stop that now. I don't need it to run any further, and I'm going to send the optimized results. Now, notice I haven't done this yet. I have not optimized the results yet. I haven't used it for anything. What I'm going to do is, now that I'm happy with the results, I'll click on that. And then come in, I am going to turn off the feature lines, although a lot of times I'll leave those on. They're great break lines. But for other things I'm going to do here, I'm going to turn those off. And I'm going to name this surface lot 1-1 for the first phase. I talked about phasing my project out earlier on, and this is what that looks like. I'm going to create a surface here, and I will go to the 1-in-5 design style so I can see it. And there you can see that where that surface diverges from the original. In fact, I'm going to take the original existing conditions and turn those to no display. And actually, I'm going to turn this surface down to the background style so that it is gray, and we'll be able to see new changes after this. Now, phase 1 was making sure that the overall site was graded appropriately. Now I'm going to put a ditch in the backyard here. I'm going to start off with a polyline and create a grading limits for where this ditch is going to be. Just a 2D polyline, regular 2D polyline. I'm also going to draw a polyline across the middle here. I'm going to snap it to the edge here, hoping to get this to drain along here. This is a drain line, and so that it'll drain off to the side here and out the end of our project there. Now I'm going to go over to the grading limit and set that for the closed shape that we have here. I am going to set this as a min slope of 1. I don't want it to be flat, but I need some kind of drainage. The max slope, I'm actually going to set that to 50. I'm not expecting any 2-to-1 slopes in here, but I'll have that just in case I run into it. The exclusive drainage is going to be important here because this area here will look at other drain lines, and it'll look at this drain line here and the one to the north. I want it to focus on the one that's inside of that area there, and exclusive drainage does just that. It turns its focus inward to the drain line that's in here. I'm also going to call this the ditch area. And that way I will see that later. I am also going to use a drain line tool for this one here. And again, the parameters are already set for that. I'll click on optimize. Now, because there's more than one surface, it's asking me to identify which surface am I working with, and then it will set up. Now, I'm about to make a mistake. I'm calling my shot here. I'm doing this on purpose to show you this. I'm going to start optimizing, but I have not changed the grading limit, the outer one yet. So if I click optimize, you'll see a whole bunch of triangles are moving. In fact, if I turn it on to this, you'll see the contours are moving. I'm like, wait a second, I didn't want that. I wanted it to only focus on that ditch area right there, that localized area. So I'm going to come back and reset this. So I go back to the starting point. Then I'll come up into this area here and go to the grading limits. And when I click it, it highlights so I can see, yep, that's the one I want to work with. I'm going to turn that one off. I'm going to leave the ditch area on. I'm clicking on it just to make sure where it is. I'm leaving the visibility of both on because they are both there and playing a role. But now with grading limits off, the ditch area limits is going to do that work for me. So now I will click on optimize again. And now notice all the changes are taking place inside that much more localized area, and the contours are moving in relation to that. Something else that happened here is the notification center popped up and said, there's something up here. I'm going to click on that, and it says the building pad and the retaining wall are disabled because they're beyond the grading limit. You know, the building pad is here well outside of that. So grading optimization actually saved me a little bit of trouble there because I did want to disable those while I was running this. So that's a good thing. Something else about the notification center is that if it sees that your design just isn't going to result in an optimized surface, it warns you as soon as possible. That way you can stop and make some adjustments. Notification center even actually tells you what things you could do here, what adjustments you could make to make your surface work inside the optimizer. So with that, with all that talking, that is done. I'm going to come over to the optimized result and sorry, it's confused as to where to look here. I'm going to turn off the feature lines and go back to the surface. Now, something else I want to mention, notice that it's allowing me to update the existing surface, that lot 1-1 that I used. Now, I don't want to do that here, but if you finished a surface and sent it out, then sent it for results, and then realized, wait a second, I've got to add something or make a change to something, or maybe you've got more different instructions about your project, you can go in and set that and add that back into this surface. In this case, though, I want to compare lot 1-1 to lot 1-2 for the second phase. And I'm going to finish that off and get those contour lines through that area there. And so now we can see how that's going to work in here, and we can see that, you know, we did get a ditch the way that we wanted to through that area. So with that, I want to leave you with some takeaways here. First of all, these are things that I want you to share with your organization. Make sure that those that are using grading optimization are aware and using well. The visualization tools are there to supervise progress, get used to them, and get friendly with them. They are going to help you out a ton as you're going through the optimization, as well as looking at the final results. Also, grading in phases may help. I have to admit that since that was recommended to me, all of the projects I've worked on, or all the things I've worked on, I've used that phasing idea, and it does really speed things up. Even though I'm having to do 2 different things or 3 different things, it actually speeds each of those up. But it also helps me focus on the localized areas when it's time for that. Drainage changes depending on where you put the encouragement. So move those around a little bit, experiment and get friendly with those drainage tools, those lines in particular, so you know how they're going to react in certain circumstances and where you want to kind of drive your grading. And finally, remember to set objectives and adjust settings. If you're at the preliminary phases, give yourself a little more speed and sacrifice a little quality for that speed. But if you're towards the end and you need a better quality, just understand that you're going to add a little time to the process, but you'll be getting a better result out of that. So with that, I would like to thank everyone for your time and attention. Enjoy the rest of Autodesk University.